Hello dear friends, once again welcome. Now let us do the problem on range. In this problem, what we have to do, firstly, let us read the statement of the problem. So reduce the forces acting on the bar as shown in the figure to a range giving the point of interaction of the range in plane A. Okay, so this is the bar and this is the plane A. And what about the axis? This is x-axis and what about y-axis? So here it is y-axis, here it is x-axis, here it is z-axis. Okay, and the system is, let us solve it one by one. And in the previous lecture, I have shown only the procedure. What will be the approach to solve this kind of problem? In this, we will discuss the solution one by one, step by step. Okay, so in solution, uh, now we have to see given force given force system consists of consisting of one force, that is, you can say here this one F1, and the direction is along the z-axis. That's why 500 Newton, and the z-axis K. And what about the direction will be positive and negative? So obviously it is negative. Okay, and what about the couples? So three couples are there. Okay, so firstly C1 is equal to, well, C1, so this is the C1 and it is 300 Newton meter. And what about the direction? It is parallel to the x-axis, that's why I. Okay, and it is positive I. Okay, what about C2? So C2 is here 300 again Newton meter. It is Newton meter. It is a Newton meter. Okay, and what about this C2? C2 is parallel to the y-axis. That's why J component here. What about C3? So C3, here it is C3 and it is parallel to the z-axis with negative sign, minus 1, 5, 0, then K. Okay, now what is the next step? So in the next step, what we have to do? We have to equivalent force and couple at O. So here O is the origin of this bar. Okay, so now we have to get the resultant force R bar here, and it is actually summation of the force, and that is equal to F1, as there is only one force vector. Okay, what about the resultant couple? So it is divided by CR, and it is actually summation of the moment about O. Okay, so moment about O hai. So for that, what is required? So R1, because there is only one force, so force and a perpendicular distance creates couple. So this one plus we have to add the couples C1, C2, C3, Okay, and what about R1? So R1, you can see here, this F1 from the origin. So along the, we can see along the y-axis and along the x-axis. So along the x-axis, this one, if you see the bar, if you see the figure, this one, so it is 3I. And what about along this one, along the y-axis? So 3I plus 3J. Okay. So CR can be written here 3I plus 3J, and it is the cross product of F1 and F1 is equal to 500K, and then plus C1, C1 is equal to what? So it is then minus 300J minus 150K. Okay, so what we get from this, here 3 is multiplied by minus 500. Okay, then what will be I cross K, and this 3 plus 3 is multiplied by minus 500, and here it is J cross K, and then plus 3I minus 300 J minus 150K. Okay, so this is equal to what? Actually it is equal to minus J. This is equal to what? It is I. Okay, so what we get, it is 1500 and J, and it is minus 1500 and I plus 300 I minus 300 J minus 150K is equal to, so this is equal to minus 1200 I, and this and this we have to add. So it is plus 1200 J and minus 150K. In this way we got CR, resultant couple. Resultant couple, this is the resultant couple. Okay, so now let us show it through the diagram. Mathematically we have shown, mathematically we are doing what about to the figure, how to represent it. Okay, so this is the Y, and this is the Z, Y axis, Z axis, and this is the X axis, and the plane lies in XY axis. So it is the plane A. Okay, and so what about the resultant? So resultant is here, you can see resultant is minus 500K. So K along this axis, and it is the R. Minus means minus Z axis. Okay, and what about where the resultant couple lies? So it lies here in this plane. You can see here, like we can show. Likewise we can show. Okay. Okay. And it is equal to what? So this here we can resolve like a perpendicular to the resultant R. This here can be resolved into two parts. So from origin O, it is O, it is O, and it is C perpendicular. And what about the, it is a, this one, it is C parallel. Okay, so C perpendicular is what? It is the one of the, there are two components, there are two components, there are two components of CR. One is, that is along, perpendicular to the, it is perpendicular to the resultant, and it is the second component, that is parallel to the resultant. Okay, so that's why the both figure, we can label the figure name is equivalent force system at O. Okay, now next, what about, we have to check whether R and CR is, both are perpendicular or not. So both are not perpendicular. So this we can verify. R is how much? It is, R is minus 500K. So it is minus 500K, and CR is what? So CR is minus 1200I plus 1200K and plus minus 150K. So let us check it. Is equal to G, is not equal to 0. Okay, so we can check here. So we can check. So it is by mistake I have written this is the J. Okay, so if K is multiplied with I0, if K is multiplied with J0, if 500K is multiplied by minus 150K, so it is equal to what? Means we are not getting 0. Okay, so what is the meaning of this? Since R and CR are not orthogonal, so reduction of force system makes a range. Okay, so now next is to get the equivalent range. Okay, so we have to get the axis of range, that is given by unit vector. given by the unit vector along resultant R, and we denote it by E bar is equal to then R bar and the magnitude of this. So this is equal to minus 500 K, and it is divided by 500. ठीक है, क्योंकि अंडर रूट 500 स्क्वायर हो जाएगा. So that's why what we get minus K here. Okay. Next is we have to get the component of R, the component of CR along R means the axis of range. Okay, and that is we denote by C parallel, and it is equal to what? So it is CR and multiplied by the unit vector. Okay, so is equal to what? So CR and along the R, and where along the R means we are talking about along the R means the z-axis. Okay, so let us take the z component of the resultant. Z component of the resultant, where it is, yeah, this one, minus 150K. So it is minus 150, then E, it is a minus K. Okay, so means it is 1. Okay, minus 1. So is equal to, we get 150, and it is Newton meter. Okay, and it is actually, you can say, the scalar component. So similarly we can get the vector component of C parallel. Okay, means then C parallel in vector form, it is the C parallel multiplied by E bar, means unit vector, and this is equal to, we have 150, and E is equal to what? So it is minus K. So minus 150K we have. Okay, now what is the next? So next, after getting C parallel, then we have to get the C perpendicular. So it is equal to CR and minus C parallel. So and C perpendicular means it is along, C perpendicular means along the which axis? So it is along so actually it is we are talking about C perpendicular. So simply we have to write here CR. So what is CR here? 1200 I, this we know, plus 1200 J minus 150K. And what about C parallel? So C parallel, it is minus 150K. Okay. So what we get ultimately, it is minus 200 I plus 1200 J. Okay, and after this, what is the next we have to do? So next is, let the range intersect the XY plane A in a point A. So x, y and 0. Okay. So what will be then? C perpendicular is equal to R, the position vector multiplied by the resultant. Okay. And this equal to what? So this already we know 1200 I plus 1200 J here. It is equal to R. R means what here? So X I plus Y J multiplied by the resultant. Okay, and the resultant is minus 500 K. Okay, so this is equal to what? So it is 500 X, and if I multiplied with K, and here Y multiplied with 500, so minus 500 Y, and J cross product of K. So what we get is equal to minus 500 X, and this is equal to what? This is equal to minus J we get, and minus 500 Y, and this is equal to I we get. So we can write it 500 X J and minus 500 Y I. So minus 500 Y I plus 500 X and J, and it is equal to minus 1200 I plus 1200 J. So now let's compare equating X component. Okay, we get minus 500 Y is equal to minus 1200, means this equal to this. Okay, so what we get? We get Y is equal to 2.4 meter. Similarly, equating Y component, then what we get? So we get 500 X is equal to 1200. Okay, so from here also we get X is equal to 2.4 meter. So hence the position vector can be written as position vector R can be written as 2.4 I plus 2.4 J, and this we can show through the graph. This is the x-axis, this is the y-axis, and this is the z-axis. Okay, and the plane, xy plane, this is the xy plane, plane A. Okay, and where will be the resultant? So the resultant will be here, and this is R is equal to minus 500 K, means it is parallel to Z axis, but where it lies from the origin, it is R distance, it is R position vector, R position vector. Okay, so since C parallel is perpendicular to the R, sorry, C parallel is along the axis of the R, or you can say parallel to the R. Okay, so this is equal to what we have, 150K. So this figure represents what? Equivalent range. So in this way we have done. So let us summarizing it, what we have done. So firstly, in this question we have identified the number of forces and the number of couples. Then we found out the resultant force. Then we found out the resultant couple. Then we checked whether the resultant force and the resultant couple both are perpendicular or not. If it is not perpendicular, means there is the range. There is the generation of the range. Then what we do? क्या करते हैं हम? Resultant couple को here, you can see here, resultant couple को components में break करते हैं. एक component होता है that is C perpendicular, and it is actually perpendicular to the resultant R, and another component C parallel, it is parallel to the resultant R. Okay, then what is the next is to get axis of the range. Okay, then after getting axis of the range, then we can get the component of CR along the R, and the component of CR perpendicular to R. This is perpendicular to R. Okay, then we have to get means the position vectors by nullifying the C perpendicular. This we are going to nullify. Okay, so instead of that, what we get, we have at the last the resultant and a C parallel. Okay, and where the resultant lies, that we get through the principle of the moment. So with this, thank you.